Okay, welcome back everyone. In this lecture, we are going to focus on Address Resolution Protocol or ARP. So, how ARP works? You know that in every local network, every device has an IP address and a MAC address. The IP address is usually 32-bit numbers that represents how the device is perceived by other devices. But if you want to communicate in a local network, for example, if you want to communicate with a PC that is connected through the same Wi-Fi or connected through a same local network, then in order to communicate with that machine, what you have to do is you need to know their MAC address, because IP address is only used when you want to communicate with the internet or the network devices that are outside your local network. What if you want to communicate within your network? To do this, you have to know the MAC address of this device. But how do we know the MAC address? To do this, or to get the MAC address of other devices, we use a protocol called ARP. So it provides a mapping between IP addresses and MAC addresses. So what this protocol basically does is that you input an IP address and it returns the MAC address of this device. And then once you have the MAC address, you can use it to communicate or exchange packets with that device. So how in this lecture we are going to focus on how we can discover clients on a similar network or a local network. So let's say we have a PC and then we have a router and then we have other devices, for example your phone, your desktop PC or something else, your iPad, whatever it is. So let's say you want to discover which client it is. So the first idea is to ping the clients, all the clients in the network, and once you ping these devices you get their responses back, and then by analyzing their responses you know what device it is. And then these devices return an IP value which represents the address of this machine. For example, let's say I'm sitting in a room and I say whose name is, let's say, John. Everyone except John will stay quiet, and then John will say yes, I am John. So basically this is how ARP works. So ARP says who is ABC or who is X, and then the person or whoever it is whose name is X or John or whatever it is, he replies back with an answer and the others stay quiet. So this is how ARP works. Okay, so in this lecture we are going to see a practical or visual representation of how this algorithm works. So first thing, you have a device, let's say this is your device which has an IP address of 192.168.0.13 and this has a MAC address which is this value. And then there is a router in your network or gateway that is used to communicate with external internet. So this address, his address is 192.168.0.1. and most of the time you will find that every router has the same address because it's a convention that is used in a local area network. And then you have three other devices. Now let's say you want to communicate with this address 192.168.0.25 and this is your machine. So how do you communicate? This PC or device communicates with this device. So in order to do this, it sends an ARP request, and there are different types of request, but this type of request will be called who has request. So what this request does is basically it sends out an IP address, and then it sends this IP address to everyone or broadcasts this IP to every device in the network. So this packet goes here, 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 and here. So every device receives the address, and once the request has reached each device, this is called broadcasting basically. So once this has, every device will verify this request with its own IP address. So this will check if the request's IP address is the same IP address as my own machine. Similarly, this router will do the same, and this machine will do the same. Once these has verified, this will return false because 192.168.0.1 is not equal to this value, and similarly this will return false and this will return false, but this will return true because this value is the same value as this one. So as I already said that you shout, for example, whose name is John, and then only John will reply because his name is John. Similarly, this device will now send back a response. This is called ARP response, and then it will say I have a MAC address of this thing with this value. So in response, it will reply his own MAC address, which is 110.A95.90.6824. So in this way, this device has an ARP table. So what the ARP table is basically a list which contains mappings of IP addresses and their MAC addresses. So something like this, for example, device number 1, their IP address, and then their MAC address. Once it gets back a response, it updates its ARP table with, for example, 192.168.0.25, and then it updates the MAC field as this value, and then it tries to communicate with it. So this is how ARP communication or ARP protocol over a network works. Let's say this one has requested google.com, and now the internet will send the reply, an HTTP reply, and it will contain the google.com files, and then these files will be forwarded to this machine. So this is the normal communication works, but there is some problem with an ARP protocol. So one of the main problem with ARP protocols is that there is no way of authentication or verifying the information. For example, if a device A sends an information to device B, the device B will receive information and then it will update its IP tables with that information without verifying if the information was correct or not. So this is one of the main fundamental problems with ARP protocol, and this is the reason why ARP spoofing is one of the most common attacks. So what happens is that, let's say there is a hacker who wants to intercept the communication or traffic that is occurring between this victim machine and the internet. So what happens is that this hacker generates an ARP response, and it tells the victim machine that I am a hacker. So it fools the device or victim machine into thinking that it's a gateway. So it will say that my IP address is 0.1 and my MAC address is this thing. It tells victim I am a router. So it pretends to be this device, but it is actually another device. So it creates a fake packet or fake ARP response, and it sends this response to this victim machine. When the victim machine receives this response, it updates its IP tables with the fake information that it receives without verifying that even if its information was correct or not. The next step is the hacker sends a second packet to this gateway router, and now it tells the gateway routers that I am a victim machine. So it fools both devices. So it tells victim that I am a router, and it tells router that I am a victim. So now these both devices have updated their IP tables, and their MAC addresses are according to this situation. So let's say if this victim wants to connect to the internet, there is no direct way, because the router IP is in victim machine's IP tables. The router is represented by this device, and in this machine's IP tables, the victim machine is represented by this machine's IP and MAC. So both these devices are spoofed or fooled into thinking that they are other devices. So now in order to communicate, what happens is that victim sends a packet to this router, but victim sends a packet to this machine thinking that this machine is the router. And then what happens is that this machine forwards this package to the router, and router thinks that this packet is coming from this machine because the information has been updated, and then it forwards it to the internet. Once it gets a response back, instead of sending the response to this machine, the router sends response to this machine, and then this machine forwards the response to this machine. So now you are completely intercepting the traffic, that instead of traffic going directly from router to this machine, it is flowing through your network, and then you can simply read everything that is communicated between these two devices. For example, let's say if this machine is sending its password or its username over the network, you can easily intercept this network password here, and then you can read what the user's password is. You can filter or sort out each of the packet that is sent, and then you can read this package to see or understand what the victim machine is doing. This is a very important security flaw in ARP protocol, and it is utilized by different hackers to perform the ARP spoofing. Welcome back everyone. So now our goal is to use ARP spoofing to perform man-in-the-middle attack. To do this, we need to first install several modules that we will use in our program. So the first thing we need to do is go to this terminal in Kali Linux and use this as a root user. To do this, you have to write sudo and then press su, and then it will ask for your password. I am already in as a root user, so let me show you how to do it. Exit. Okay, so now I am a normal user in Kali Linux. To go into a root user, I have to write sudo su, and then it will ask me for my password. Since I have already done this, this is not asking me for password, but for you this will ask for a password. Once you are a root user, you need to install a package. To do this, you have to write sudo apt-get install, and then you have to write dsniff, and it is already installed in my computer, so it's not installing, but for you this will ask you to install it, and you have to press Y to install it. So once you have this, you will have access to ARP spoof package in Kali Linux. So as you can see, mine is version 2.4, and then it tells you how to use it. We will see in next lecture how to use it, but if you write ARP spoof and then press -H, it will tell you how to use this module. Okay, in next lecture we will learn how to use it. Okay, so now we are ready to do ARP spoofing, but before doing this we need to set up some things so that our Kali machine is enabled to track or identify packages. To do this, we have to enable IP forwarding in our Kali Linux machine. So what this do is that it will help us in transferring the packages from our victim machine to the internet and from the internet to our victim machine. So it will act as kind of a tunnel between them. For example, if IP forwarding is blocked in Kali Linux, then the user will not be able to access the outside internet even if you complete an ARP spoofing attack. So you will have access to the packets, but these packets will not be forwarded to the internet, and the user will know that something is wrong. So to do this, you have to enable IP forwarding. To do this, what you have to do is go to the terminal, clear this out, and then you have to write system control, which is sysctl space, and then you have to provide wv, and then you have to select the IP forwarding package or file. To do this, you have to write net.ipv4.ip_forward. So this is the configuration file, and then you have to modify this configuration file in your Kali Linux machine, and then you have to set this parameter equals to 1. So once this parameter is set to 1, this will enable us to forward packets from or to our Kali machine. So if you press enter, you can see that it has set this value equals to 1. So now packages will be able to transfer. So if I press ARP-A, you can see that we have an IP table which maps the interface to our MAC address, IP to our MAC address. So in next lecture we will learn how to do ARP spoofing attack. Okay, so now we have installed the ARP program. So in this lecture we are going to spoof both the victim machine and the router in believing that we are the other device. So we will move forward like this. So first we will try to spoof the victim machine with ARP spoofing and tricking him to think that we are the router, and then we will trick the router into thinking that we are the victim machine. So before we proceed further, so I have put out the ARP tables of this Kali machine as follows. So as you can see that currently it shows that the router is at 0.1 and it says that it ends with MAC address with something like DC, and it says that the victim machine ends at colon A7. So if you go to the Windows machine and see that now it has the same correct mapping of router to MAC addresses. So it says that router, which is 0.1, is at with DC, and the Kali machine ends with BD. So now we will try to first spoof the victim machine into thinking that we are router. So this field of Windows machine will be replaced with our MAC address, which ends with BD. So if I go to the Linux machine again and try to spoof it, so what I need to do is I need to write ARP spoof, and then I need to provide the interface, which would be ETH0 in our case. Then I need to provide the target. So there would be, since we are targeting the victim machine, so first we need to provide the IP address of the victim machine. So 192.168.0.30 space, and then the device that we are pretending to be. So since we are hacker machine and we are pretending that we are router, so that the victim machine send packets to us, so we will write the router's address here. So 192.168.0.1. So now we are tricking the victim machine into thinking that we are router, but we are actually not router. If we press enter, you will see that it will start spoofing the victim machine. And now the victim machine thinks that we are at BD MAC address. So if I go to the Windows machine, and now if I try to write ARP-A, you will see that now the victim machine has updated its ARP table. Now the router, which is 192.168.0.1, is the machine thinks that it is at this address, while previously it was at this address, which is the correct one. But now we have spoofed the victim machine into thinking that our router address is this one, which is actually the address of our hacker machine. So now we have achieved one side spoofing. So we are now tricking the Kali machine into thinking that we are the router, and now victim machine is sending packets to our machine. So now what we have to do is we have to do the same process on the router side. So now we will try to spoof the router into thinking that we are the victim machine. So I'm going to go over to the Kali Linux and I'm going to start a new terminal. Now I'm going to do the same process here, which is ARP spoof -i ETH0, and then I need to spoof the router now. So I will say 192.168.0.1, and then I will pretend to be the victim machine. So 192.168.0.30. So now I am pretending to be a victim machine. And what's the issue here? ARP spoof. Oh, okay, so I left the -t tag here. -t. If I press enter, now this is spoofing the the router machine. Now we have completely spoofed both the devices. Now the victim machine thinks that we are the router, and the router thinks that we are victim machine. So now all the traffic that will flow from victim machine to the router or internet will pass through our network or our machine. So in order to capture this, what we are going to do is we are going to use Wireshark. But before doing this, let's stop this lecture here and I will proceed in next lecture. Okay, so now we have two spoofing programs running in parallel which are spoofing each of the devices, that is the victim machine and the router. So the next thing we need to do is we need to check how can we capture packets. To do this we will use Wireshark. In first part of this series we will use Wireshark, then we will write code to capture these packets manually. But for now we will use Wireshark to see how these packets are flowing through. So as you can see at the moment, this Wireshark is capturing each and everything that is going over the network. But what I want to do is I want to capture packets that are just flowing from my victim machine, that is my Windows machine. So to do this, what I have to do is I will try to say ip.source equals to 192.168.0.30. So what this filter will do is that it will only capture those packets that are originating from my Windows machine. So now it will not filter packages that are it will filter out packages that are going through my Kali machine or originating from my Kali machine. So now we have this, and then we need to do is we need to perform some operation on our Windows machine so that we can capture these packets here. So I'm going over to my Windows machine and then I'm going to open the browser. Okay, so let's access google.com. So now I have performed some operation on my Windows machine. If I go over to my Kali machine, you will see that I do not have any captured packets. This is because now the packets are not originating from my Windows machine, but since I am on my Kali machine, these packages will be originating from my Kali machine. So what I have to do is I need to tcp dot let's do it like this. Go to Windows machine, clear this out. Now I will try to ping google.com from here. So I will write ping www.google.com. so it will send 4 packets to the google.com and this google.com server will reply. So I'm just going to copy this address of this Google server, and then I'm going over to my Kali machine, and now I'm going to write ip.source equals to this IP address, or ip.destination equals to this IP address. So whatever packages are originating from this server or going to this server will be captured here. So as you can see that now I have captured different pings. So this ping originated from my Windows machine, which is here, sorry, not here, here. So this originated from my Windows machine and it went to Google server. Similarly, these are the same requests that went from my Kali machine to the Google server, and then the Google server replied with these packages to my Windows machine. So as you can see that I sent out 4 packages and I received 4 packages. You can simply say that, let's remove this. So now I'm only accessing the request from the Google machine. So now you can see we can capture packages, and if I click over these packages, you can see that I can check out the content of these packages. For example, let's say I go to Ethernet, then I can check that which is the Ethernet layer protocol here, and then you can see the source and destination. So this package was originated from the Windows machine. It went out to the Google server, and then it contains various other fields. For example, time to live. It was a request, I think. This package was not delivered, but it was still sent from this Windows machine. So this is how you can capture packages. In next lecture we will try to build a program that will be similar to Wireshark, and then we will try to capture packets to our own program, and we won't rely on this Wireshark. Okay, so now we know how to spoof the machines, for example victim machines and router. Our next step would be to develop a program so we can capture packets. So in previous lectures we captured packets using a Wireshark, which is a built-in tool in Kali. In this lecture we are going to build our own program that will help us in capturing packets. So, and this program will be more optimized to our needs, and we can learn how to capture packets and write code for it. So for example, if we want to steal passwords, etc., or something like that, we can develop a very specific program for that. So to capture packets that are going over the network in the Kali machine or Golang, what we have to do is we need to install certain packages. So the first package that we need to install is from Google, and it is called GoPacket. To install it, open the terminal as root. So now I am as a root user. So the next thing we need to do, I need to install the packet. So I'm going to write go get github.com/google/gopacket, press enter. So this will start downloading the package. Since I already have installed this package, so it does not take a lot of time, but you might have to say, for example, give permissions or something like that. Once you have installed it, you can go over to Golang and start coding. So now we have installed a program that will help us in capturing packets. The next thing we need to do is we need to learn how to use this package. So in order to do it, let's first start working with finding devices over the network, and then we'll try to work with these devices. So first we need to use a sub package called pcap. So this package is also a part of Google GoPacket library, and we need to use it. So the first thing we need to do is we need to find devices on our machine. So we can say pcap that find. So I have to install it here for go get github.com/google/gopacket. In previous lecture I installed GoPacket as a root user. Now I also have to install it as this Kali user, so I can find it here. So I'm going to write pcap.find, and it may take some time to get it. So let's clear it. Let's restart the program. Goland. Okay, so now we will use this package pcap to find devices. So I'm going to write pcap dot find all devices, and you can see that it automatically imports a sub package which is pcap from GoPacket. So this is going to return, if I open documentation, you will see that it returns an interface which contains a list of devices and an error if it finds no device. So let's store this in a variable called devices and an error. So the next thing we need to check is we need to check if there is an error while finding devices or not. So if error is not equal to nil, I can log.panic ln error. If there are devices, then we can iterate over these devices and try to figure out what devices they are and what is their IP addresses. So to do this, we can iterate over for index and then device equals to range, and then we need to provide the list or array of devices, which would be devices. In this case it would be a list of interfaces. Then we can simply print out the device name using fmt.println, and then we can provide which index is it, and then we can say device.name, and this will return out the name of our device. Once we have this device name, you can, if you write device dot, and you can see there are various options, and then there is an option called addresses, which contains a list of addresses. So this addresses will return a list of addresses that are associated with this device. So we want to print out all the addresses, so we create an internal loop here. So let's say for error we are going to ignore the error, and then I'm going to say address equals to range of device dot addresses. So now we are iterating over each address. Now what we need to do is we need to print out the address and its subnet mask. So I'm going to say fmt.println \t. The first we are going to print out IP. So I'm going to say address dot IP, and this will print out the IP of this address, this device. Then we will print out subnet mask. So I'm just going to duplicate this. So press Ctrl D, and this will duplicate it. And then we are going to print out net mask, which would be address dot net mask. Okay, so now we have a program which finds the devices on the network and then prints out their name and their corresponding IP addresses. So I can just run it by using go. Okay, just run it from the terminal. So currently where are we? Okay, so we are in the root, so I want to go to go, and then let's see cd source, and then I want to go to packet capturing, and this represents the file that we just created. So I'm going to clear it and run it from here. So go run p1, and you can see that it is searching. So it says that there is an error, which is, so you saw in that in our previous lecture we got an error which is that it cannot find a C++ file. So this was because of a missing library. So what you have to do is you have to install this library packet capturing library in Unix. So I'm going to press enter, and it will take some time to install it. And then I can run my file again. So now you can see that this is run properly. So I'm going to clear it and run it again, and you can see that now it finds two interfaces, ETH0 and LO, and then any netfilter log, netfilter queue, and Bluetooth. So these are all different Unix interfaces. So we are only interested in this one at the moment. So the first one is, this represents what is our IP address. So this is the IP of our Unix machine or Kali Linux machine, and then it tells us what is our net mask, and then this also represents the IPv6 address and IPv6 net mask. So this is how you can find devices. In next lecture we will start building on our current program. We have learned how to find devices over a network. So to do this, let's create a new file, p2, and it would be called capturing packets. Let's create the main function. Okay, so the start of this program will be the same. So I'm going to copy this file and paste it here. So now we have a list of devices that we can work with. The next thing we need to do is we need to check if this device is present or not. So to do this, what we can do is we can iterate over this list. So let's create a loop. So we can say for the moment ignore the index, device equals to range devices. So now we are going to iterate over the devices. The next thing we need to do is we need to check if the device is actually the interface that we want to capture on. So to do this, what we have to do is let's create a constant here, variable, and then create an interface. So let's call it, we want to capture over the interface called ETH0. So now this is the interface that we want to use to capture packets. The next variable we will define is called device found equals to false. So if no device is found, we can say that this is false, this variable, and by default we are setting it as false. So here we will check if this device name is equal to the same device that we have declared earlier. So let's say if device dot name equals to interface, we can say that device has been found. So we can set this device found variable to true. Device found equals to true. So if our program finds the interface which is the same interface as ETH0, we can say that we have successfully found a device. Once we have this device found, we can proceed further, and then we can check if the device found, if not device found. So if we don't find any device, we can simply exit our program with log.panic, and then we can print an error here and say that, let's say device not found, device not found. Instead of panic-ln, we can use panic-f, and then we can set the device name as well. So it would be %s, and just remove this error, just say interface. So now we have put the error checking in here. So in next lecture we will proceed further. So in our previous lecture we saw how to capture packets. Now our next goal would be to start capturing packets. So in order to capture packets, what you need to do is you need to create something called handle. So you can create handles using pcap library. So to do this, you have to write pcap dot open live function. So what this function does is that it takes in several parameters, and then it returns a handle. A handle can be thought of something as like a connection or a tool that is used for capturing or filtering packets over a network. So as you can see that it requires several parameters. So the first thing it requires is a device name, then a snapshot length, then promiscuous, and then timeout. So I will explain each of them in detail. So before I go here, I need to create certain variables. So I will go here and I will create some variables. So the first thing we need to create is snapshot length. So snapshot length would be defined as the length of data for each frame. For example, how much data you want to capture in each frame. So to do this, let's say I'm going to create snap length, and then it would be of type int32. And then we need to provide the length. Let's say I want to capture 1600 bytes per frame. The next thing you need to do is you need to define a timeout. So I'm going to create a variable called timeout, and then I want to block this block the filtering capability till our program recommends or wants to. So we can use pcap dot block forever, and this will block forever. This will start capturing packets till the program exits. So it will stop execution at this timeout, and then it will start capturing and displaying packets continuously and again. So then we need to define variable called filter. So as you know that when we are working with Wireshark, we defined several filters, for example tcp.source and tcp.destination equals to something like that. So in this program we have to define certain filters, but these filters are specific types. For example, these are called something, I think BPF filters or something like that. So what their goal is that they have a specific syntax, and you need to follow this syntax in order to create a special filter for these type of capturing. So let's say I'm going to show an example filter, and then you can read more about them on the internet. So let's say you want to create a packet that is of TCP, transmits over TCP protocol, and then we want to capture communication that goes over the HTTP or HTTPS protocol. In this example, I'm going to show you an example over HTTPS protocol, which is a secure protocol. So I'm going to write TCP and port, and then the port number, which is 443. So now we have a device name here, snapshot length here, timeout here, and filter here. So let's go here and open it, and let's see the documentation once again. So the first thing is device name, which would be our interface, and then the snapshot length, which would be snap length in our case, and the third is promiscuous. So let's create a new variable here. Promiscuous mode equals to, set it to false. So promiscuous mode means that we want to, if it is true, we want to capture everything over this interface, but we don't want to do this. We want to capture only certain packets. So I'm going to call promiscuous here, and its value is false. And then the last thing it requires is, if you open documentation here, is timeout. So I'm going to provide this timeout, which is block forever here, timeout. So now we have a function which takes an interface, snapshot length, promiscuous mode, and timeout, and then this function will return a handle, and then we can work with this handle to filter or capture packets. So it's going to return two variables, handle or error, if there is no, if it cannot create any handle. Then we can simply check for an error. If error is not equal to nil, we can simply panic and exit. And in next lecture we will learn how to use this handle to filter and capture packets. Okay, that we can work with to capture packets on the wire or network. So the next thing we need to do is we need to write a defer statement to handle the closure properly. So I'm going to write defer handle.close. Okay, then now that we have everything set up, our goal would be to set a filter that we will use to filter capture packets, because we don't want to capture everything going over the network, as it will clutter our screen. So first let's set up the filter, and then we will start capturing packets. So we can use this handle to set filters, and we can use a method called set BPF filter. So if you search the documentation, you will see that it compiles and sets a filter to this handle, and then this handle will try to filter only those packets that have this special feature, which is defined by this filter. and note that we have defined this filter over here, which is TCP and port 443. So only packages that contains the TCP protocol and that are passed through port 443 will be captured and printed out by this filter. So let's check for an error so that we can be sure that the filter has been set up properly. So we can say if error is not equal to nil, log.panic_ln error. So now we have a filter set up. Our last step would be to start capturing packets. So in order to do this, we first need to define which is our source. So we know that our source is this handle, but we also need to define how do we decode these packets from this source. So we are going to use goPacket dot new packet source. So this function returns a source object which we can use to iterate over these packets that it captures. So the first thing it requires is a packet data source. So our packet data source is our handle, so I'm going to give my handle object here, and then it needs a decoder. So how do we decode these packages? So we will decode these packages using link layer. So I'm going to write handle.link type, and then this is our decoder. So this function is going to return an object called source. So okay, so if I go over here and check documentation, it says that new packet source creates a packet data source. So it contains a stream of data packets which can be read and then printed out. So in order to read these data packets, what we can do is we can iterate over. If you check the documentation again, you can see that it creates a packet data source, and then we can iterate over this packet data source using something like this. So I'm going to write it here. So let's start iterating over this source and checking which packets we get. So we will create a for loop, and then we will say each packet equals to range source dot packets. Okay, this source dot packets will give us each packet will give us packet continuously, and then we can use these packets to find out what is their content. So this function returns a list of packets which we can iterate over each time. So let's say we just want to print each packet. So now we will just print out whatever packets that are going through the port 443. So now our function is complete. So let's remove this. So now we have everything set up. We are creating a handle, and then we are setting filter, and at the last step we are simply creating a packet source, and then we are reading packets over the live wire. In next lecture we will run this program and see how this program works. Okay, so now we have created a program that can capture packets. So in this program what we are going to do is I have already started an ARP spoofer. So what this program is doing is that it is spoofing the router and also spoofing the victim machine. So both these devices are being spoofed. So what I'm going to do in this lecture is I'm going to run this program, and then I'm going to see which packets are being sent over this network from the victim machine. So let's go over to the victim machine. Okay, so now I am over a victim machine, and now what I will try to do is I will try to access this twitter.com and see if I can get any packets over to the victim machine, over the hacker machine. So let me check if I have started my program. So I am going to start my program here. So go run p2, and this will capture packets. So I'm going to Windows machine, and now I will refresh this page, which is twitter.com. And now if I go over to my Kali Linux machine, you can see that I have a lot of packets going on. So I will stop the execution. So let's start examining these packets. Okay, so let's start with taking this packet. So this packet is, if you see clearly, that the source IP is 192.168.0.30, which is our victim machine, and currently we are on our hacker machine. And then the destination field is 93.184.220.70, and this is the IP address of the Twitter server that I was accessing. And you can see that it has printed out all the details about this packet. In further lectures we will see how to access the content of this packet, but at the moment we are just checking out the main fields of this packet. So let's stop here, and in next lecture we will try to build a program to check out the payload or the data of this packet. Okay, so in our previous program we only just printed out the packets. In this lecture what we are trying to do is to see what the data or packet contain. So what we'll try to do is to get the payload in a separate packet, and then we will try to print out the payload instead of printing everything. And this will give us a more brief and concise version of our packet, and then we can look for details or things that we are looking in our packet. For example, if we want to steal credentials from a user, let's say a user connects to a site which is not secured, which is, for example, an HTTP site instead of HTTPS site. What we can do is we can filter out the traffic through our program, and then we can search for usernames or passwords in this text, because in HTTP protocol the data is sent in a normal text form. So what we can do is we can capture the packets and look for these fields, and if we find something like matching, we can simply print out the usernames and or passwords. In this way we can steal their credentials. So this is what we'll try to achieve in this program. So instead of printing everything in the packet, what we will do is that we will try to get the application layer of this packet. So if you are familiar with OSI stack, it says that an internet packet or datagram can be represented in 6 basic or 7 basic layers depending on which model you are using. So the topmost layer is the application layer, and we will work with application layer in our program. So what it means is that let's go ahead. Here we will try to get the application layer data. So to do this, what we can say is packet dot application layer, and this will return an object which will contain an application layer. So we will store it in a variable called application layer. So now we have an object that contains the application layer. The next thing we need to do is we need to check if the layer is empty or not, because sometimes there are packets that does not contain any application layer and they only contain layers or protocol layers that are below them. So the first step would be to check for application layer. So we can say that if application layer equals to nil, we can simply skip everything, continue. If it's not nil, we can proceed further and start digging deeper into the application layer. So we can get the payload by using simply application layer dot payload. So this will return all the data or payload of this packet. Once we have this packet, we can parse this packet. This is a sequence of bytes. So what we can do is we can search for a specific thing, for example a username or a password in this string, in this sequence of bytes, and then we can print out if we find something that matches our representation. So let's first create a search array. This represents the things that we are looking for in this payload. For example, if we are looking for username or password or something like that, so we can create a string array, and then let's say we want to search a name or username or something like that. So I'm just going to give several parameters. You can modify this list on your own, and then we will iterate over this search array and check if anything is matched with this string with this payload. So what we can do is we can say for, and then we can ignore the index, and then we can take each element at once, and then we apply the range operator. Search array. Our goal here would be to search if any string matches with the payload, so any one of our strings matches with this payload. Excuse me. To do this, we can use strings.index package, and this will return the index of the matching point if there is a match, and if there is no match, it will return -1. Excuse me. So I can say strings dot, and then I can say index. So this will require two elements: first the string that we want to search, and then the entry that we want to match. So the entry that we want to match is S, and the string that we want to search is payload. But this payload is in the form of bytes, so we will convert it into form of string here by using casting operation, and then we will provide payload. The next step would be to search the substring, which would be S, and this will return an index at which point it matches the string. So for example, if the string is if this string matches with the payload at, for example, some number, for example, let's say this payload contains 1000 bytes, and this name is matched at 500, so this strings.index will return 500 in this index value. The next thing we need to do is we need to put a check for index if it is -1 or not, because if it is -1, it means that we don't find any match here. So we can say that if index is not equal to -1, we can simply print out the index, println. So now our payload is in the form of bytes, so we will convert it into a string. And then what we want to do is we want to print out this index, and then we will print out 100 bytes, because most probably the username will be located in the 100 bytes that we want to use. So we will say index, and then we will say index plus 100. So what we are essentially trying to do is we are trying to get the username or password printed on our screen. So now we have our program complete. Note that this will not work with HTTPS, because HTTPS only contains encrypted data. So in order to get it, we have to use some insecure site which only uses HTTP protocol. So instead of port 443 which is used for HTTPS, I am going to use port 80 which is used by HTTP protocol. And now we will use some website that will help us in printing our data, that will help us in stealing credentials. So in next lecture we will try to do this. Okay, so now I have my ARP spoof program currently running, and it's spoofing both the machines, Kali machines and the router. Now what I want to do is I want to steal credentials, and I have written the program for that, which is this one. So now what I want to do is I want to go to a Windows machine and try an HTTP website and try to get their login credentials here. So what I will do is I will go to the Windows machine and I have this website called Typepetra, something like that, and it has two fields, username and passwords, and it is an HTTP website, which means that it is not secure. So let's go to the Linux machine and start this program. So let's clear it out first. So go run p3, and now it will start capturing. Now I will go to my Windows machine, and I will try to put my credentials here. Let's say I say Fahad123, and then in the password field I will say test123, and then I will press login. Now it will send data to over HTTP protocol. If I go to my Linux machine, you will see that I have something printed out. If you can see that we have a name field and then it has name 123, and similarly it has password test123. So in this way you can steal credentials by using ARP spoofing over an HTTP site. Note that this does not work on HTTPS site. In order to achieve this on HTTPS website, you have to use something called SSL strip. So SSL strip will bypass this HTTPS, and then we can use the same method on this program as well. Hi, welcome back everyone. In this lecture we are going to develop a remote access tool. So a remote access tool will give us access to a remote victim, and then we can use this access to do whatever tasks we want to do on the intended victim machine. So every communication or transmission of data between these two devices will be programmed in Golang. We will develop two programs, the first one for the victim and the second one for the hacker. The feature of these victim or malware is that the malware will try to connect automatically with the hacker, that is our machine. We don't have to do anything. You just have to run the victim machine once, and then every time a hacker wants to gain access to this victim, the victim will always be trying to connect to the hacker server. And then we will develop a feature in which we will have an ability to perform or execute commands on the victim. For example, we will type commands from our hacker system, and then these commands will be sent to the victim, and then similarly these commands will be executed on the victim machine, and we will get the results back to the hacker system. And then we will also try to develop the program in such a way that we can have a long-term access to this system, to this victim, so we don't have to worry about it every time we want to connect to the victim or not. And then we will also develop a feature in which we upload and download files from the victim machine. This can be very helpful in data theft and also for stealing passwords, etc. Okay, so the first thing we will do while developing this program is that we will create two programs, one for the server or hacker and the other one for victim or client. And then the first thing we want to do is that we want to write a program that will try to establish connection between these two devices. So our first step would be to create a package to handle these connections properly. Once we have these connections, we will be able to build on these connections and develop different features that we'll explore later in our lectures. So we have two machines. The first one would be a Windows 10 victim machine. So our victim will be a Windows 10 machine. And then we will have a hacker, which will be a Kali Linux machine. So we have two devices at the moment, and then we will try to stack this victim through this hacker or Kali machine. We will write a server program for this hacker machine, which will always be listening to victim or incoming connections. And then we will have a victim program that whenever we run it, it will try to connect with the server automatically. The IP address for the hacker machine will be 192.168.0.13, and then for the victim it would be 192.168.0.30. So I will try to keep this constant throughout the creation of this malware, so you don't get confused. I have predefined these IP addresses, so it's not a problem when you go through these lectures. Before going into the detail, let's start with what our methodology will be. So our first step would be to listen for incoming connections on server. So our server program will always be listening, and then while the server is listening, we will create a victim program that whenever we run a victim program, it will try to communicate with the server. Once the victim communicates with the server, there will be an establishment of a connection, and then these two devices will acknowledge each other connections. For example, the server will tell that I've got a connection from the victim, and similarly, just for our understanding, we will print out a statement on the victim machines that will show that we have established connection with the server. Note that we want to be in victim program, we want to be as discreet as possible, but here since our goal is learning, so we won't be keeping much of like privacy. In this case, we will print out statements on the victim machines as well, but you will see at the end that we will try to make the victim program as invisible as possible so we don't get detected, so there will be no screen output on victim machine while we run the programs. But during our learning phase, we will print out different statements on our victim machine so that we can have an idea of what is happening on a victim machine. Okay, once there is acknowledgement of connection from both sides, the next step is to start sending data or communicating with other device. So firstly, we will create a program that will send data to the hacker, and then we will receive data from the hacker, so we know that we have a proper working connection between these two devices. And then once we have everything set up, we will start building on top of this and start creating more and more advanced features. So this is shown graphically here. We have a victim PC here, and then we have a hacker PC. So a hacker is always listening, and once the victim machine tries to connect with the hacker, we are establishing a connection between these two devices. And then once the connection is established, the hacker sends an acknowledgement to the victim machine. Similarly, a victim machine sends an acknowledgement to the hacker. Once this acknowledgement and initial connection is established, we will try to send data from hacker to the victim machine, and then similarly it can go from victim to hacker as well. So it's a bi-directional communication. So that's it for this lecture. See you in next one. Okay, let's start writing our server program. So this is the program that we will use to control or monitor our victim. So first things first, we need to write a program to establish the connection. So in this lecture, we are going to write a program that will help us establish a connection with the victim. Okay, so let's start writing. So first we need to create a variable called connection. This variable will be used to establish connection with our victim. So the type of this variable should be net.con. Okay, and this is a part of net package, as you can see from here. So once you have it, you need to define your victim IP and victim port. In this case, we don't need, since this is a server and we will try to connect from victim to server, so we don't need the IP address of the victim directly here. So what we are going to do is we require the server IP. So in this case, the server IP is, where is it? Let me clear it again, and ifconfig, and you can see that the server IP is 192.168.0.13. So I'm going to copy it, and I'm going to create a new variable called IP, which is the server IP of this Kali Linux machine, and I'm going to paste the value. Then I need the port to connect with. I'm going to create a port variable, and then you can use any port, but I'm going to use a port number called 9090. So now we have a victim. Now we have an IP address and a port number for this local machine that will be used to connect with the victim. The next thing is we need to define a port complete address. So a complete address can be defined as follows. Yes. So first thing you need is IP, and then you need to add a colon, and then you need to add the port. So port P should be capital. So in essence, it looks something like this: 192.168.0.13, then comma, and then 1990. So this is how you define an address. And the thing about this net package is that it requires address in this format. So we have converted this thing into this format. So now we have this. The next step is to create and to try to listen to the incoming connections. To listen to the incoming connection, we are again going to use a net package, net and dot, and then we are going to use a method called listen. And then what this method does is that it tries to listen on incoming connections. So the first thing we need to define is the network protocol. So since we are going to develop a TCP server, we are going to write the network as TCP. The next thing is address string, as you can clearly see from here. And if you see the documentation, you can see that the first thing is a network type, which could be TCP, TCP4, TCP6, or whatever Unix are. And the next thing is address, and the address should be IPv4 address in this format, which is here. So I'm going to use this local address here. So now we have created a listen method, but this method will return two objects. The first thing is a listener object, which will be used for listening on incoming connections, and then an error if it is unable to create a listener. Okay, once we have that, I'm just going to handle this error so we don't get into any problems. And then I'm just going to print an error. Let's leave it like this, log.fatal error. So now we have handled our error properly. The next step is to accept the incoming connection if there is an incoming connection. So what happens is that it starts execution from here, and then it starts waiting here for incoming connection. So the program does not proceed further from here until there is an incoming connection. Once there is a connection, it will accept the connection. Listener.accept. And then this listener.accept will return the connection object, which is here of type net.con, and if it's unable to accept it, it will cause an error. Okay, let's leave it here. Okay, now we have an established connection here. So now this connection can be used to transmit data. But here we simply want to acknowledge the establishment of a connection. So first I'm going to handle the error. If error is not equal to nil, log.fatal. Okay, I'm just going to print it that error connection cannot be established. Okay. So once we have handled error, the next step is to find out what the IP address of the incoming connection is. So I'm going to write, go here, else. Okay, fmt.println. So now we can say connection established from, and then we can get the IP address of the victim by doing like this: connection dot remote address dot string. So what this will do is that it will return out the name of this IP of the victim machine. So fmt.println. So now we have everything complete. So we write the IP address of our local machine, then we try to listen for incoming connection. Once we are listening, we can accept the connection if we have an incoming connection, and once we have accepted it, we can just print out the IP address of incoming connection here. So this is the server side of the program. Now we will define the victim side of this program in the next lecture. Okay, in this lecture we are going to write a victim program. So the victim program will try to communicate with the server, but first we should check out the server IP. Okay, as you can see that the server IP is 192.168.0.13. So I'm going to copy it, and then I'm going to write it here as server IP. Once we have a server IP, we need to define the port as well. So I'm going to use the same port, which is 1990, which we defined earlier. Then we have to write this in address form as we did earlier. So I'm going to call it local address, server IP plus, and then this should be in braces, and then the port number. So now we have address defined. The next thing, we should dial to the server. So we can dial to the server using net.dial method. So I'm going to use net.dial. Okay, if you hover over its documentation, it says that it requires two arguments. The first one is the network, which would be of type TCP, as it is mentioned here, and then the address. The address should be this thing, which is server IP plus port. So I'm going to write TCP here, and then so it shouldn't be local address, it should be server address. Sorry for the misunderstanding. So it should be server address. So now we have this server address. This is going to return two parameters. The first one would be a connection, and the second would be an error. So firstly, we will handle error. So if error is not equal to nil, I'm just going to print out that error connection couldn't be established with the server. And then I'm simply going to log out whatever the error is. Once we have handled the error, the next step is to print out the successful connection. So I'm going to use connection.remoteAddress.string. So what this method does is that it returns the IP address of the server. So I can use this in a print statement like this. So I'm going to write a statement here like connection established with it. So this will tell us that this connection has been successfully established with the server. So that's it for the client program. Now in next lecture we will try to run these both programs and see how things go. So see you in next lecture. Okay, so in this lecture we are going to first learn the server program, which will start listening for incoming connections, and then we will run the client program that will try to connect with this program while this program is waiting for incoming connection. Once the connection is established, these both programs will acknowledge each other connection properly, and then we can see that the connection has established properly. So first let's run this program. Go run vim.go. As you can see that now this cursor is blinking, which means that it's waiting for incoming connections. Now let's go to the Windows system. Let's clear this out, and now I'm going to run this program, and now this program will try to connect with the server. So now as you can see that this cursor is blinking, and after some time it says connection established with 192.168.0.13. And similarly, if we go to the Linux, you can see that it says that connection established from, and then the port of the Windows PC from which it tries to connect. So only the incoming port should be same. This port can be different. For example, victim, which is the Windows 10 machine, it can connect from any port, but the only port we need to take care of is the incoming port. So this port should be 9090 for here, and the Windows machine can use any port to connect with this server. So that's how you can communicate with clients and server. So this really has nothing to do with hacking, but this is the building foundation for building our program. So basically what we did was just establish a connection between the server and client using a normal TCP connection. So it can use for a lot of other applications, for example building a chat application or communicating data with the server or client, but this can also be used for malicious purposes, which we will do in this series. But okay, so that's it for this lecture. See you in next one. So when our code gets complicated, we don't have any problems compartmentalizing our codes. So the first thing we need to do is we need to create a new directory, and I'm going to call it core. So this core will contain all the functionalities of this program. The main file will just be used to communicate with or do the very basic things, and all the functionality will be defined inside the core. So inside the core we'll define a new package, and then we'll call this as handle connection. So this package will help us in handling our connection, for example communicating with the victims, etc. Similarly, we'll use or define the same type of logic in the victim machine as well. So once we have that, we can use this code to create further features, for example sending data, etc. So now in the handle connection, I'm going to create a new file, and I'm going to call it establishing a connection or something. Establish connection. So once we have this package, I'm going to create a new function here. So I'm going to call this function as connect with victim. So the functionality of this function will be that it will take two elements. The first element will be IP address, which would be of type string, and another will be the port, which will also be of type string. And then it will return two things. The first one is connection, which would be of type net.con, and then in case of an error, it will return error. Now the first thing we need to do is that if we go over here, we know that we have to define our address in this format. So I'm going to just copy it and paste it here. So now we have a local address. The next thing we also need to do is to create this connection. So I'm going to copy this here, and then I'm going to paste it here. So now what we are essentially doing is we are organizing our code to make it more readable and also to see what's happening behind the scenes. So I'm just going to copy all of it here, copy, and then let's paste it here. So now we have everything set up. There is just a few things we need to know. So instead of printing error here, I'm just going to return the error here. Return connection and error. Similarly, if everything goes well, I'm going to remove this and just returning connection and error. Similarly, if the connection is successful, I'm just going to return it. Return. If we have already defined the return types here, we don't need to write it again here. So now we have a function called connect with victim, which takes in an IP address and a port number, and then it returns a connected object if we have a proper connection. So let's go to the main function. Okay, and now what we need to do is we need to get rid of everything here. Okay, let's do one more thing. So we have removed everything from the main function except the IP address, the port, and the connection variable. So now we are going to use this and connect with victim function to get a connection back. So I'm going to write connection error equals to connect with victim. connect with victim, and then I'm going to give my IP address and port. So as you can see that this is much more clearer than the previous variant. So we simply have a connection which handles all the internal communication, and at the end, if there is no error, returns a successful connection, otherwise returns some error. Now we can print out the error here. If error is not equal to nil, we can just print out lol.fatal, and then whatever the error is. Okay, the next thing we need to do is we need to defer our connection, so we close the connection properly if everything goes wrong or something. So this defer statement will help us in closing our connection at the end of this at the end when the program goes out of scope. Okay, what else? And then we will simply use this connection object to print out a successful connection statement. Connection established with, and then I'm going to write connection dot remote address dot string. So now we have simplified the server version of our program. So we put all the functionalities here in this package called handle connection, and now our main function looks much more cleaner. In the next lecture, we will do the same process with our victim. Okay, so in this lecture, we are going to do the same process. I'm going to create a new package called handle connection. Main.go. So now in this package, we will create a function called connect with server or hacker. And similarly, it's going to take two things: IP, which is of type string, and port, which is of type string 2. And then it is going to return connection, which would be of type net.con, and then an error, which would be of type error. Now, the next thing we want to do is we want to dial the server. So I'm going to copy this line. Okay, I'm going to copy everything from here. Let's just cut it and paste it here. And then we need to convert this IP and port into the server address. So I'm going to copy this as well. So let's call it server IP. Oops. IP. So now we have almost everything set up. So I'm going to remove this, and I'm just going to call return here. Similarly, if everything is successful, I'm going to return it here. So if there is an error in connection or dialing, then we will simply return an empty connection and an error which contains the error which states the reason for for not connecting this. And then if everything goes well, we return this connection object which contains a connection to the server. Now come here. We need to define the IP addresses, which we have already defined here, and then we have to define port, which is here, and then we need to handle connection. So I'm going to call handle connection dot connect with hacker, and then what we need to do is we need to provide the IP, which is going to be server IP, and then port, and then it returns connection and error. Okay, next thing we just need to handle errors. If error is not equal to nil, log.fatal error, and if everything goes well, we'll just print out but first we need to close the connection properly, and then we can print out whatever our statement is. For example, fmt.println connection established server, and then the server IP address, which would be connection dot remote address dot string. So now we have everything set up. Now we will just run these programs to see that they're working properly. So let's go to the Linux version and clear it, and then go run main.go. Now you can see that this is waiting, which means that it's working properly. Now let's go to the Windows machine, clear it again, and then go run main.go. Wait for a few seconds. How long it's going to take. Okay, so now the connection is established. So as you can see that it says connection established with server, this one, and if you go to the server, you can see that you get the IP address of the victim, which is 0.30, and then the port it uses to connect. So now we have organized our code properly. Now in next lecture we will build on top of that and start creating more functionalities in this core. So that's it for this lecture. See you in next lecture. Python, you can simply use the input function, for example, to get the input, but in Golang it's quite different. So I'm going to use this reader, and then we need to provide the reader. So in this case our reader would be standard input, that is the input we give through keyboard. So I'm going to use os.standard input. So now we have a reader that will help us in reading the input from the user. So we need to store it in some variable, and now we have a reader and we can use this to get input from the user. So let's start with writing print statement. So we know that the reader is waiting. So whenever we see these two greater than signs, which means that now the reader is ready to take input. So next we will write out whatever the data we want to send. So let's say data to send equals to reader dot read string. So now we will use this read string method to get the user input. So we need to define when should we stop taking input. So we want to develop a program that whenever we press enter, the user should know that now all the input from the user is finished, and then you can store whatever he wrote to this data to send variable. So we need to define a delimiter byte. So since we want to stop taking input when we press enter, we are going to use delimiter byte as \n, which is a new line character. Okay, so if you go over here, assignment mismatch, so there is an error too, so we need to handle this error as well. Let's start handling an error. If error is not equal to nil, then we can simply say log.fatal and then error. If we read properly, then we can send this data to the client or victim using this connection. So I'm going to write connection.write, and then it requires an array of bytes. So I'm going to define byte, and then I'm going to type convert this into byte. So I'm going to write type data to send. Once we have that, it returns two things. The first is the number of bytes that is written on a connection, number of bytes, and the other thing is error if it's not written properly. So if error is not equal to nil, log.fatal error, and if everything goes well, I'm just going to print out the statement that number of bytes written equals to number of bytes, and instead of using printf, I'm going to use println. So now we know that our data has been sent properly over this connection. Okay, the next step we will need to do is to read this data on a client victim. In next lecture, we develop a program to read this data. So now we have developed a program that will send data to the victim. So in this lecture, we are going to develop a program that will receive data from the server. So the first thing we need to do is we need to define a procedure how we are going to receive this data. Since the data is sent over the connection which is of net.con type, so we are going to use the same connection to receive the data. But we first need to define a reader in which we are going to read our data. We are going to use the same buffer input output that we already defined .newReader method, and then we will define what type of reader we want to use to receive data. Since in this case we don't have to read input from the user, but we need to read input from our connection, so I'm going to use reader as our connection. So now we need to store this reader in a variable. I'm going to call this as reader. Once we have this reader, we need to read the string that or data that we sent. To do this, I'm going to use reader dot read string. So the read string works in a very different way. So as we know that whenever we input data on the server side, we wrote our data, whatever our text is, and then we press entered and it stopped taking input from the user, and then it sends the whole data plus the new line characters \n along with this data combined, and it sends it over the connection. Here we have to receive the same data, so we need to define a delimiter byte as well. So our delimiter byte in that case was \n, so we can use the same delimiter byte here to tell the reader that the input has finished, or data coming from the server side has finished coming. So I'm going to use \n as the delimiter byte, and then we need to store this data in something. So I'm going to create a new variable called data received, and then this reader dot read string also returns an error, so I'm going to handle that as well. First, let's handle the error. If error is not equal to nil, I am simply going to log.fatal error. Once we have handled the error, the next step is simply to print out whatever the data is. fmt.println data received. So if you simply just print out this data received, what will happen is that this data received already contains a \n character, so it will create extra spaces in our program. But we can use strings function, which is strings dot trim suffix, and then we need to give the data received, and then we want to define which suffix we want to trim or remove. So I'm going to use \n. So what we want to do is that we want to remove this \n character from the string which is at the suffix or end of this string. What this whole method will return a same string with and removes this suffix from this string. So I'm going to call this data, and then instead of printing this data with the new line character included, I'm just going to print out the simple data, whatever it is. So CLS. Okay, so the next step is to send data and check how the program works. So to do this, I'm going to go to the server side, which is the Kali Linux side. Okay, sorry. So my Kali Linux has updated, and there are a few changes in this setup. It means that now this Kali Linux is non-root by default. So for example, previously we could write ifconfig and this program will run properly. But now, since it is non-root by default, previously it used to say root at Kali, which means that our default user was root and we could do anything. But Kali Linux has improved their security, and now the main user is not root by default. You can convert it into a root, but by default it's not root. So in order to use it, you have to use sudo or super user do command, and then you have to write whatever command you want to write. I'm going to write ifconfig, and then you have to provide password. I provided my password, and now you can see the same commands run perfectly. So this thing has changed in Kali Linux 2020 version. So enough of this Kali update. So let's go here and clear this out. Okay, now we want to run this server program. So I'm going to start this program, which is go run main, and then I'm going to my Windows machine and I'm going to run this main program as well. So now our victim is trying to connect with the server. It will take some time, so I'm going to the server again, and let's wait for this program to connect properly. Okay, as you can see that it has obtained connection from 0.30, which is the Windows machine, and now it's waiting for the input, which is indicated by these greater than 2 signs. So our program is currently here and it's waiting for reading string from the standard input. So I'm going to write string as Fahad Ali. That's it. Okay, so I want to send this data, which is Fahad Ali, to the victim. So note that I haven't pressed enter yet, so it's waiting for more input. So let's say if I write some garbage text here, and then whenever I press enter, it stops taking my input from the standard input. So I pressed enter, and note you can see that it completes this statement, which is data to send, and it then writes the bytes to connection, which is this one. And now, since the bytes are written, we have to see if the bytes are written properly or not. So I'm going to the Windows machine, and now as you can see that we have received the exact same data here, and this data has \n removed. If we did not write this statement, which is trim suffix, then there would be 2 new lines or blank lines here, which is instead of 1, which is here. So this is how you can communicate with from server to the client, and this is a very basic example of how to communicate with data. As we will move forward, we will start building on this application, and then we will try to send more and more complex data, and including files, which will help us build a more complicated malware program. So that's it for this lecture. See you in the next one. Okay, now you have seen how we can send data over a network in a very simple terms. But as you may have noticed that this method of sending data has several problems. One of the main problem is that you can only send a very rudimentary or fundamental type of data. For example, if you want to write a string that has 2 lines, you cannot do that, because whenever you press enter, the code will stop taking further input and it will send whatever was written to the function. Now what we can do is that there are different methods of overcoming this problem, because this is a very common problem in networking. For example, how to send data. So there are solutions like serialization, encoding, etc. So what we want to do is that in this case we will focus on sending a struct over a network. So what we will do is that we will define a struct in server side, and then we will try to send this struct as a whole over the network to the client side. For example, let's say we have a file, for example it says, "Hi, how are you?" and then we have a new line called "I am good." So as you can see that this cannot be sent over our conventional method that we studied earlier. So if we say, "Hi, how are you?" what will happen is that it will stop taking input at this point, and then this "I am good" will not be taken since it encounters a new line character here. So this means that it can only take a very rudimentary type of data, for example string, and you cannot send other type of inputs, for example integers or floats or bools, whatever you want to send. And also you cannot send files using this method. This problem can be overcome with using a gob package. So gob was developed by Golang to overcome this problem of sending data structures over a network or a communication link. So what happens is that there are different ways. For example, every language has its own way of sending it. You can send it using XML files, using JSON or protocol buffers, but I'm going to focus on this gob encoding. So this gob is a special type of encoding, and you can read it about it here. So you can read how gobs of data work, and it defines why do we need gobs to send data over a network, or how we tries to send it. What else? So it gives us an example, for example how to send it. We will do this example now, then you will be able to understand how to send data. So the first thing we need to do is we need to define a struct, and then whatever data we want to send, we will define our data inside the struct, and then we will encode the whole struct and then try to send this struct over a network. For example, let's start writing and then type, let's name the struct. For example, let's call it data struct, and then we will define types. For example, let's say I want to send my name, which would be of type string, and then I want to send my ID, which would be of type integer. Similarly, I can send other types, for example my age, let's say it's float. As you can see that this data is quite complicated, and it can also contains custom types. For example, if I create my own data structure and then try to send this data structure, I can also define it here, and then I can send this whole data struct in one go, and I don't have to worry about anything. So let's say stick with the 3 fields just for now. So now we have a struct. The next thing we need to do is we need to fill in the details of this struct. So what I'm going to do is I'm going to remove this whole thing. So now we have to fill in the details of this struct. Let's say the first thing I will do is I will set the values for these elements. So what I have to do is I have to create a struct equals to, and then I will give a reference to this struct, which is data. The next thing is I need to define values. So I'm going to define name as John Smith, and you can see that this can contain multiple values. For example, if I want to write \n here, and then I write something like John Smith, John Doe, So let's say he somehow has a name that contains a new line character. It doesn't make sense, but I'm just giving an example. And then he has an ID called, let's say, 50, and then age, let's say 50.34 or 43 years, whatever it is. So now we have a data structure, and we have to send this data struct over our network. So what we can do is we can use gob.new encoder. Since we want to send it from our server to the client, we have to first encode this data into the gob. So I'm going to use gob.new encoder, and then what connection we want to use, or writer. So since our writer in this case will be our connection, that is the connection or channel that we want to use to send or write data. Once we have that, we have to associate with this, we have to encode this. So let's store this in an encoder. So now we have an encoder that sends data using this link. The next step is to encode this data or this data struct. So I am going to use encoder dot encode method. So this method, whatever data structure we give, this encodes this data structure, and then at the same time it sends the data over this connection, and you don't have to write, for example, encoder dot send data or something. So whenever you call encode, it automatically encodes the data, and at the same time it sends the data over the network. So I'm going to use the data here. Okay, and then it returns an error if it's unable to send data. Then we can simply handle this error and know if the data is sent properly or not. Fatal error, else we can just print out that the data has been sent successfully. So this is the server side of how you send data. What's the issue here? Okay. So that's it. That's how you encode your data and send data over a connection. So in next lecture we will define a similar procedure, and then we will try to decode this data on our victim side. Okay, now we have sent the data from our server side. In this program we are going to receive the data on our victim. So the first thing we need to do is we need to define the same data struct that we defined on our server side. So it contains name and then whatever the fields are, and note that the fields must be the same data as we are sending on our server side. If there is a mismatch, there would be an error in sending data. So the first thing we need to do is we need to define our gob decoder. So we can use almost the same procedure, which is gob dot, instead of using new encoder we will write a new decoder, and then we will define which connection we want to use, and then we are going to store this in a decoder. Once we have the decoder, we can use this decoder to decode message, but before decoding it we need to give a reference to our data struct. So now we are creating an empty data struct, and then we will fill in fields using this decoder. So to fill in fields, what we have to do is we can use decoder.decode function. So this decoder.decode function will receive data from this connection, and then it will automatically store the data in this object or struct. So once we give this data in the input, it automatically stores the data in this data structure, and then it returns an error if there is a problem. The next thing we want to do is we want to handle our error. So you can say if error is not equal to nil, log.fatal error, and if there is no error we can we can print out our data. So I'm going to print out a statement called successfully decoded data, and then we can print the data. For example, name, and then we can use this data structure dot name field to print out the name. Similarly, okay, so there was a small problem in the previous program. We need to send these fields in an exported way, which means that the first letter of these variables should be a capital letter. If they are small letters, you won't be able to send them. Please convert the fields of this data structure to a capital letter. Once you have that, you can go to the Windows machine. You can do the same over here and you can update them. No, that's not Windows machine. Okay, so you can do the same in Windows and change these values. Replace the name and age with the capital letters. Once you have done this, you can simply print out their values. So if I'm going to the Linux machine, clear this, and then I start my server, and similarly if I go to Windows machine, clear this again and start this and then wait, you can see that successfully decoded data. And then you can see that John Smith, John Doe 50.43, and then the ID, whatever ID I sent. If you go over to Linux machine again, you can see that now we have a \n character, but this does not affect the sending of our data. So in this way we can send data properly over a network. So that's it for this lecture. Okay, so let's start moving forward. Our next goal will be to execute commands remotely on the victim machine. So what we want to do is we want to send commands from our hacker system, and then we want to execute those commands on the remote machine or the victim machine. And when the command is executed, we want to know the results back on our server machine. So this is basically remote command execution. So this is a very important feature in hacking. For example, if you get a shell or a remote access and then you can execute commands on the remote system, then you can pretty much do anything on their PC. So this is one of the very important features of remote access tools. So let's start writing code for command execution. So the first thing we want to do is we want to create a function. Okay, let's go here, and then we will name this as execute command. Execute command Windows. So what we want to do is we want to execute commands on the Windows PC from our server, which is here. So to do this, what we need to do is we need to create a module or package. Now I'm going to create a new file called execute, and then we will develop functions in this. So the first function we will write is function called execute command remotely Windows. So we want to call this function, which is execute remote command, from here so that we can access or run commands executely. We will define the logic of this function later, but let's for the moment go here. Okay, so now we have an established connection. What we want to do next is to create a loop here so that we can again and again execute commands or do different procedures. So what we want to do is we want to create a loop here that will run commands or do other functions depending on the user input. So we will determine the logic as we go along. So the first thing we need to do is we need to get the user input. So we are going to use the same procedure, that is we will create a reader which will be of type buffer input dot new reader, and then the input type will be standard input. So the hacker will enter commands on his own machine or on the Linux server. Once you have this command, you can use this reader to get input from the user and then determine your program your code accordingly. So let's start moving. Okay, our next step is to create a loop. So to create a loop, we will define a loop control variable and its initial value will be true, and then we will define a for loop and we will iterate over this loop. So note that since the value of loop control is true, so at the moment this loop will always be true, but we don't want to do it like this, and we will define our logic as we move along. So once we have that, the next step is to simply get the user input. So I'm going to write printf, and then we will ask user to enter options. Okay, so here we will ask user to input options, whatever options you want to enter. The next step is to read the user input. So I'm going to create a new variable called user input, then raw error equals to reader dot read string. So this is the same read string function that we were using previously. So once we have read the user input, we can simply check for an error. If error is not equal to nil, we will print the error and then we will continue the loop. Continue. Okay, so now we will get input here, but what is this input? So this input should be some option that we select from our features. So we will develop different features, for example execute commands, download files, etc., or upload file to the victim. So I will start building the logic. So the first command or first option that we will build is called execute commands, and we want to execute commands remotely. So I'm going to create a function here called options. So these are the options that we will develop during our execution. fmt.println. So our first would be execute commands. So this option will help us in executing commands. What's the issue here? Okay, let's leave it forward. Okay, so what we want to do here is we will call this options here, and then every time we loop through this, every time we loop, we will get the list of options we can select from. So I'm going to call options here, and then we will have options here. So let's define one more option. So if we want to exit the program, let's say, so we have at the moment two options. Either we can execute commands or we can exit the program. So whenever we call this function, we will get list of different options that we can execute. So it kinds of give you choices or options that you can select from. Once you have that, let's proceed further. Okay, so our next step is to write this user input to the connection, so that the victim program also knows which command or which action is being performed. So I'm going to call it connection dot write, and since it requires a byte array, I'm going to call user input. So now we have sent our command or whatever our command is to the victim, so the victim knows which command is being run. Once you have run the command and victim both knows, you can proceed further. Okay, now since this command already has this \n attached to it, our next step would be to remove this \n and get just the pure option. So I'm going to use the strings.trim suffix function, and then I'm going to call it user input, and we want to remove \n from this, and then I'm going to store this in a new variable called user input. Alright, so now we have this user option input, which could be either 1 or 99. Keep that in mind. So now we will switch, we will develop a switch case, and then we will use this as the condition variable. So I'm going to write switch user switch case user input equals to 1. Okay, so fmt.println. So now we are in our command execution program. Here we will execute commands, and here we will call this function which we have defined in our package, which is execute remote commands, execute command remotely with Windows. So I'm going to call it here, and then I'm going to use the package name, which is execute command Windows. Okay, let's remove this one. Okay, if you go here, you have to define the inputs and the outputs. So we are going to input connection, which is of type net.con, and then we are going to return an error if there is an error. So let's return it here, go here, and then connection, and this is going to return an error. The next step would be to print out this error, but what we want to do is we want to define a generic function that will write and that will take in this error and print out its message, so we don't have to write this error condition every time. So I already have defined this function, which is called display error, which takes the error and simply prints it if there is an error, otherwise it does nothing. As you can see here, it simply prints out the error. So I'm going to call this function error here, display error, and then simply I'm going to give it the error. Okay, so our first condition is almost complete. So we will select the option 1 when we want to execute remote commands on the victim machine, and then this function, which is execute command remotely Windows, will execute commands remotely on the Windows PC. So let's define a default case as well, if we for example give a wrong input or something. So I'm going to call it I'm going to say that invalid option, try again or something. So now we have a switch for which if we press 1, we will go to the command execution method, and if we press any other value, it will again ask the user that input the try again because your input is invalid. So that's it for this lecture, and then in next lecture we will proceed further. Okay, so now we will define another case for exit condition. So if we want to exit our program safely, we can just enter 99 and the program should terminate perfectly. So let's define a case called case user input, and then we will check if the user input equals to 99. and if the user input is 99, we can show a message that program exiting, and then we will set this loop, where is it, loop control to false, so it exits the program. So now if we press 99, the program will show a message that it's exiting, and then it will set this loop controls to false, and the control will move out of the loop here. Okay, and then we will define more or less the same logic on our server program to handle these statements or commands. Okay, so that's it for this lecture. Okay, so now we will build our victim program. So the first thing we need to do is we need to get the initial options message from the server side. So we have to store the options. So let's start with creating a reader which will read the options from the server side. So buffer input output dot new reader. And then instead of using standard input, we will use this connection because we are sending the options from our server side, and this connection we will use to receive these options. So we have created a reader. The next step is to create a loop control similar to the server program. So loop control is equal to true, and then we will create a for loop here. So now we have created an infinite loop here at the moment. So the next step is to read the user input. So I'm going to use reader dot read string, and then I'm going to use a delimiter byte, and then I'm going to user input raw. I'm going to use the same variable name so it's easy to understand. Okay, so let's handle the error first. If error is not equal to nil, what we are going to do is we are going to print out the error, and then we are going to skip the loop. Okay, so once we have that, the next step would be to remove this \n from this raw input that we are receiving from our server or hacker. So let's use strings.trim suffix user raw input, and then \n. Then we are going to store this in a new variable called user input. Okay, so the next step would be to now switch over this user input, the similar process that we did in our server or hacker program. So let's switch and then define different cases. So the first case would be if user input equals to 1, which is our first case. So now we want to execute commands here on this PC. So I'm going to this message called executing commands on Windows. Once we have that, now the next thing we need to do is we need to create the command execution package here, similar to what we did in our hacker machine. So I'm going to call it execute system command Windows. And then I'm going to create a file called execute, and then in this file I'm going to create a function called execute command Windows. Now let's set the arguments here. So this function is going to use connection, which would be of type net.con, and it's going to return error if there is any error, and it's going to return the error if there is something problematic with the program. So let's go to our main program again. So as so far we have defined a logic that will if the user input is 1, it will go to this program or block, and then this here we will call this function, which is execute command windows. So execute command windows. As you can see, it automatically selects all the packages, and then we are going to pass connection to it, and this is going to return an error. So similarly, what we did in the previous program, we are similarly going to use this display error function to print the error. So I'm just going to call display error. So now we have our first case as set up. We are going to define our second case as well, which is for exiting condition. So it's 99. And be careful of these codes. So each code will correspond to a specific feature. For example, 1 will be used for executing commands, 99 will be used for exiting or closing the program safely, etc. So let's just print out a statement here, and then we will call this exiting the Windows program. The next thing we need to do is we need to set the loop control as false, so that when we input 99, it goes out of this loop and closes the program perfectly. And then we are going to define a default case which will just show a message if there is a wrong input. Print ln invalid input, try again or something. Okay, so now we have defined the main logic here. Now in next lecture we will start developing these functions. Okay, so now our focus should be development of this function, which is execute command remotely Windows. So if we go here, we don't have any logic defined here, and now we'll start building our logic here. So if we want to execute commands, what our logic should be that we should send command from server, then execute command remotely, and then receive back results or error if there is an error. So this is how the algorithm works. So you send the command, a remote victim executes command, and then sends back the results. But what we want to do is that we want to write a program that will ask the user continuously for the commands, and then it will execute commands again and again unless there is a special condition. So our logic will be like this. So we will send a command, and then it will return a command, and then this will root forever unless there is a special condition, and this special condition will be stop. So we will write different commands, for example directory or present working directory. These are all Windows commands, or let's say some other command, for example date. So we will try to write a loop that will iteratively ask the user to input commands again and again, and it will give back the results automatically. But if the user input stop, then this command loop should stop, and it will move out of this loop and go back to here, and then ask the user for options again. So this will be our logic. So let's start building it. The first would be to get user input. So we will define a new reader, and then we will get the input from user. Once we have this input, we will define a command loop now. Loop equals to true, and then we will loop over this command loop. Okay, so the next step is to just fmt.print, and then simply we will ask the user to input commands, which is, and these arrows or greater than signs indicate kind of like when, for example, if you open a terminal, you see something like this and we want to replace it with this thing, so our terminal would look like this. Once you have that, the next step would be to read the user input. So we are going to use reader.readString, and then \n as our delimiter, and then we are going to store this as command. Then we are going to handle our error. If error is not equal to nil, we are going to print the error, and then we are going to continue. So we skip the loop and then try to get the input again. Alright, so the next step would be to send this command to the victim machine. So simply I'm going to use connection.write byte and then whatever the command is. So we are simply writing the command to the victim machine, and then the next step would be to check for the type of command. So if command equals to stop, then we will enter the exit condition. So here we will set the command loop to false, and now this control will move out of this loop and back to the main function. So this is our stopping condition. The next step we need to define. So as you already know that if we write a different command, for example dir or something, then the result is usually multiple lines. So what we will do is that we will try to develop a command struct that will give us results back to the hacker or server PC. So as we already know how to send structs over a connection, in this lecture we will define a new struct. So let's call it type, and it will be called command struct. Okay, and this will contain two fields. The first would be the command output. Be careful to write these fields as capital letters so it doesn't cause any problems, and it would be of type string. And similarly command error if there is an error while executing our command. So we have a struct, and then we will send this struct, we will receive this struct from our victim. Now our logic is defined here. So we are sending the commands to the victim will execute commands, and then it will return the results in a struct. So I'm going to define the struct here. So I'm going to call cmd struct equals to and command. So we will create an empty struct because the results will come from the victim machine, and then we will write a decoder. What we will do is that we will encode the results in our victim machine, and then we will send the results here, and here we will decode the results. So I will write the logic for decoding here now. So let's create a decoder first, is equal to cob.new decoder, and then connection. The next thing we want to do is decoder.decode, and then give the struct, and then handle the error. So if error is not equal to nil, we can just print out the error and then continue with our loop. Okay, so if everything goes perfectly and we get a command struct with the valid fields of output and error, we can simply print them. For example, fmt.println command struct dot command output. So whatever the output is, we will print it, and then we will check the condition. So if command struct dot command error is not equal to empty strings, then we can print this fmt.println command struct dot command error. So if there is no error, this string will be empty here, and if there is an error, we can just simply print it. If the command struct is not equal to this thing, yeah, okay. So now we have our server side complete. Now in next lecture we will build our victim side. Okay, so in this lecture we are going to build our victim program, which will execute commands on this PC, which is our victim, and then it will send back the results to our main server that we already defined. So let's first create a struct which will contain two fields. I'm going to use the same naming conventions, which is command struct, and then there will be two fields, command output, which would be of type string, and command error, which would be of type string. So now we have our struct complete, so it's output, not out. Okay, the next thing will be to get user input. Before creating getting user input, receiving input from the hacker, we first create a reader is equal to buffer input output dot new reader, and this will receive data from the connection, and then we will create a command loop similar to what we did in our hacker program. And then we will loop over this. So now we have an infinite loop at the moment. The next step we want to do is we need to get a raw user input. So raw user input equals to reader dot read string, and then the delimiter byte, and it returns two elements, so it returns error as well. So if there is an error is not equal to nil, we can simply print out the error and then continue the loop again. And if there is no error, we check for user command. Okay, so firstly we remove the \n character from our user string, so it would be raw user input and then \n, and then this is going to be called user input. Okay, let's move here. So first we will check if the user input command is stop or not. If user input equals to stop, then we will simply set the command loop to false. If it's not, then we will go into else condition. Okay, so in else condition we need to do some certain things. Firstly, since we need to execute this user input or command on our PC, what we need to do is we need to define certain variables. So we will define two variables, variable output, and it would be of type bytes.buffer. Similarly, we will create variable standard error, and it would also be of type bytes.buffer. So we have created two variables. One will contain input and the other will contain error, and they are both of the types buffer. So whatever the error is in the standard buffer, in the buffer, we can get the inputs using this. We can access them using these variables. Okay, so firstly let's print out the command for better understanding. So we can say that user command is something like user input. Okay, so now we have printed out the user input. The next step is to execute this user input or command on the system. So in Windows we can do it in a different way, and in Linux we have to do it in a different way. Let's start with it. Okay, so we can use the exec.command function to run this command on the Windows. In Linux we can simply write, for example, ls, and this will work properly, but in Windows this does not work properly, so we have to define logic for both. So let's say we first check which operating system is it. So, and this can be done by using runtime.goos. So this returns if it's Windows operating system, it will return Windows, and if it's Linux system, it will return Linux. But we are going to write the program only for Windows and Linux, so we will define logic for just these two. So we can say that if it's a Windows command, execute here, and if it's Linux, then we can say that execute here. Okay, so the next thing we need to do is you need to use the execute package. So you can say execute.command, and then we need to define certain things for Windows. So the first thing we need to define is we need to set the type of shell or application we want to use. So in Windows we will run our commands in PowerShell. So we will write PowerShell.exe. Okay, so the next parameter is \c. So this will set the starting drive, for example, which drive to use. And then we need to write the user input a user command. Okay, so to run this on Windows, what we have to do is we can use if runtime.goos equals to Windows. We know that the operating system is Windows, and then we can use we can write the execute command for Windows, which is execute.command, exec.command, and then we have to write the several arguments. The first one is the name of the program that we want to write. So Windows have two programs, cmd.exe and PowerShell.exe. CMD is very basic, and in this program I am going to use the PowerShell. So I'm going to write PowerShell.exe. Okay, the next argument is \c, which is the drive, and then the last element is the user command, user input or user command. So once you have it, it returns command instance and you can store it. If the operating system is not Windows, you can write an else statement, and then you can say execute.command, and then simply the user input. Then you can store it in command instance. Okay, once you have that, the next step is to define the inputs and outputs of this. As you already know, we have defined this buffer and output and command output. I'm going to cut them here and paste them here. So they are essentially buffers, and we can use these buffers to read and write the standard input output. So what I'm going to do is that I'm going to point the output and input of this instant into these variables. So it would be standard command instance dot standard output equals to output. Similarly, command instance dot standard error equals to command error. So I changed the name of this error to command error because it was conflicting with this error. Command error. Okay, so the next thing we need to do is simply to run the command dot run and store the error. Okay, then we have to check for error. If error is not equal to nil, what we can do is we can print out the error. Right, then last thing we need to do is we need to store these elements in the struct, and then we can send them to our server machine. So let's create an empty struct called cmd struct equals to and command. So now we have an empty struct. The next thing is to fill the values. So I'm going to call cmd struct dot command output equals to out dot string. So I'm going to store this output, which is in bytes form, into a string form, and then I'm going to store it into this struct. Similarly, I'm going to do the same with error. Command struct dot command error equals to command error dot string. So now we have our struct complete. The next thing we need to do is we need to encode this struct and then send it to the hacker, which is already decoding it since we have defined the logic. Let's create an encoder equals to gob.new encoder, and then we have to define the connection. Once we have the encoder, we can use this encoder to encode and then provide the struct, and it will return an error if there is an error. The last thing we need to do is you need to check for errors. So if error is not equal to nil, we can simply print the error and then we can continue. So now we have our logic defined properly. What's the issue here? Okay, so it should be referenced to this object, not the object itself, because the type is different in this case. Now we have everything complete. In the next lecture we will run this program. Okay, before we proceed further, there was a small error that I made. Go to the server program, and in the execute command function, I forgot to add the \n here, so the function was not working properly. Okay, so now we have everything set up. Now in this lecture we are going to start our programs and see how they work. So first thing, we need to start our server program. So I'm going to write go run main.go, and now this server is listening for incoming connection. If I go to Windows and start the program go run main.go, you can see that now it's trying to connect, and now it has connected properly. Now if I go to the server again, you can see it asks me for option. So the first option is execute commands and the second is exit. Now I want to execute commands, so I press 1. Now you can see that it says command execution program and it's asking for commands. So now here I can write Windows commands. You can see that I'm running a Linux PC, but I can write a Windows command. So if I write ipconfig, you can see that it returns the result, which is the same as the ipconfig result on Windows. You can see that the IP of the Windows machine is 192.168.0.30, and it shows that Windows IP configuration. Similarly, if I run another command, let's say directory, you can see it lists all the files present in the current directory, which is C, users, test, go, source, and victim final version. And then we have three files, .idea file, core, and main.go, which is here. So the idea file is the file for this Goland, and then we have a core directory, and then we have main.go file, which is 1173 bytes. Similarly, for example, this program also has error checks. So for example, if I misspell a command, let's say if I try to write ls, which is a Linux command and not a Windows command, so if I press enter, okay, since we are running PowerShell, so PowerShell supports ls command as well. But if we were running command prompt, then this command won't work. So let's try, so let's misspell this command lsl something, and if I press enter and wait for a few moments, you can see that it returns a proper error which says that the term is not recognized as name of command, etc, etc. So now the program is working properly. So now if I want to go back to the main menu, I can simply write stop, and now it goes back to the main command, and then from here I can again go to one command execution and I press stop again. Now it goes back to the main program again. Now if I write 99, it will exit the program, and similarly if I go to the Windows machine, you can see that it exits the program safely. So you can see that our program is running commands on the remote PC in a perfect manner. Okay, so that's it for this lecture.